Hi, in this video we are going to discuss containers and what it means to developers. To tell why we need containers, we will start with bare metal servers and see what prompted the transition to virtual machines and then to containers. So let's get started. Before virtual machines and containers existed, how did we deploy a web application? We needed a host machine, can be a bare metal server, then have to install an operating system in it. Next would be a web server installation on the operating system, and after that we will deploy our application into the server. Then to take it online, the server has to be connected to a network, where it can accept requests and send back responses, and now we have our application online. Simple, right? It is all going smooth. But the problem arises when we have another app, particularly an app built in another technology stack. We will have a tough time installing the second application in the server. Even if we manage that, then the potential race conditions will hurt us. It will be a terrible conflict story to handle, two of our applications fighting for the same port. And to get out of this situation, we will have to isolate the applications. That's exactly where virtual machines comes to our rescue. We would take the host machine and install a hypervisor in it. Hypervisor allows us to virtualize the hardware, and we can run multiple virtual machines utilizing the same hardware. Each of our app runs like it is running on its own dedicated piece of hardware. This definitely is better utilization of resources. But not the best. I will tell you why. In many cases, when you are running multiple VMs, each of those VM may be running the same OS, but still there got to be different OS installations supporting each of the VMs, thereby wasting disk space and memory. If this is not a good reason for us to search for a better alternative, here is another problem. For us to bring our application running on a VM to life, the OS has to boot up, and it is a time-consuming process. To save us from the problems of disk and memory wastage as well as slow boot-up speed, here comes the containers. The containers will still need to have physical hardware to run our apps. But we are no longer virtualizing the hardware. We are using the container engine to virtualize the OS. This is an important difference with VM. So if we host our different apps in their own containers, they will work like they're on their own dedicated OS and dedicated hardware, but in reality OS and hardware are shared across these multiple virtual environments. And there are advantages, as we are no longer duplicating the OS in disk and memory, we have more room for our apps. Also, a container doesn't require us to boot up an entire virtual machine, making it easy for us to bring up containerized app online quickly. They are also lightweight, because they don't need the extra load of a hypervisor. They can run directly within the host machine's OS kernel. Then what about the isolation? Well, that is still there. The apps can have different dependencies, and use resources in a way that will not conflict with each other. From a developer perspective, if you are used to CI/CD pipelines, there is nothing much that changes when it comes to a containerized dev environment. And if you are into iterative development, this will make your process much more efficient, because the containers not only contains our app, but also dependencies and configurations. We don't need someone to go out and install right version of a software in an environment for our apps to work. Instead, we make sure that we build the correct environments for our app and ships it in the containers. Today when we think of containers, one of the first thing that comes to mind is Docker, and let us see what Docker is in our next video. Thanks for watching.